This video is going to have a look at particles and moles. Now by the end of this you should be able to use the terms moles, mass, MR, concentration and volume. And concentration should be able to work out in moles per decimeter cubed and grams per decimeter cubed. It would help if you've watched the video on moles, mass and MR from the additional topic, which I will link below, before you watch this video. There are three equations that you need to be able to use for this exam. Moles is mass divided by MR, concentration in grams per decimeter cubed is mass divided by volume, and then concentration in moles per decimeter cubed is moles divided by volume. Provided you can use those and remember those, the questions should be fairly straightforward. So if you had a question, like what is the concentration of in moles per decimeter cubed of a sodium hydroxide solution with a concentration of 0.4 grams, what you would be expected to do is work out from that equation what information you know. Now, it's asking for moles per decimeter cubed. Straight away I'd look at this one, and I want to work out the information there, so I need the moles and I need the volume. This here tells me a lot about my question. It tells me that I've got 4 grams for every decimeter cubed. So I can take that as my mass is 4 grams and my volume as 1 decimeter cubed. Now, the next thing I need to look at is I need to work out the moles. I've got the mass now, the MR, which is the total mass of sodium hydroxide, which is 23 plus 16 plus 1, allows me to do this calculation, which is 4 grams divided by 40, which is the mass divided by MR, which gives me 0.1 moles. I've now got moles, I've got volume, which is 1 decimeter cubed there, so the concentration is moles divided by volume, and moles divided by volume is 0.1 divided by 1, which gives me a concentration of 0.1 moles per decimeter cubed. Another example question is a solution of ammonia, NH3, in water has a concentration of 2 moles per decimeter cubed. How many moles are there in 0.5 decimeter cubed? So straight away I've got a volume and I've got a concentration in moles per decimeter cubed. I want that. So moles is concentration times by volume, which is 2 times by 0.5, which is 4. 4 moles. The second part says what is the relative formula mass. Now that is the mass of the molecule. So I've got 14 plus 3 times 1 for hydrogen, which gives me a mass of 17 overall. And the final question says what is the concentration in grams per decimeter cubed. So that's this equation here, which is mass divided by volume. I've got my volume, which is here, and I need to work out my mass. So mass is moles times by the molecular formula. I've worked out my moles here, which is 4. I've worked out my molecular formula here, which is 17. So mass is 4 times 17, which is 68. And then concentration is mass divided by volume, which is 68 divided by 0.5, which gives me 136 grams per decimeter cubed. The final question we're going to have a look at then very quickly is this one. So it says what is the mass of copper sulfate, which has got a relative formula mass of 159.5 dissolved into 500 ml of water with a concentration of 0.5 moles per decimeter cubed. The first thing I would do, as I've done here, is straight away that volume is not in decimeter cubed, so convert it. So divide by 1000 to get it into dm cubed, which is 0.5 dm cubed. Now the next thing is saying what is the mass. So I can use this one here, and I can use this one here. It's also saying I've got a volume of 0.5 and I've got a concentration of 0.5 moles per decimeter cubed. So I'd be looking at this one here and what information I can find out. Because I've got concentration and volume, I can work out the moles. which is 0.5 moles per decimeter cubed times by 0.5 decimeter cubed, which gives me 0.25 moles. The next thing I need to do is, I've got the moles, I've got the molecular formula. What else can I use? Moles, molecular formula, that's how I work out my mass. So mass is moles times my molecular formula, which is 0.25 times by 159.5, which gives me 39.9 grams to the nearest 1 decimal place. There are lots of practice questions about on this. Have a go at them. If you're stuck or if you need any help on it, come and see me at any time. This will only appear in the higher paper.